Hey folks, and welcome back. Good to see you all. Hope you all had a wonderful Thanksgiving. We're going to be starting our new unit today, unit number 4, which is all about chemical bonds and compounds. Chemical bonds are what hold together compounds, so we're going to be talking about all that kind of good stuff. Today we're going to be getting into kind of an introduction of how compounds are made, and then we're also going to be talking about the different kinds of compounds that we will be encountering. Now, before we do that, we need to review a few things, the first of which are ions. Ions are charged atoms of the same element that have different numbers of electrons. And it's the fact that they have those different numbers of electrons that causes them to become charged. Remember that atoms can become either positively or negatively charged, depending on whether or not they are gaining or losing electrons. The way that we show ions is with this notation here, where we are drawing the charge on the upper right hand side. So this is sodium with a +1 charge. We could also have oxygen with a -2 charge, right? Lots of different ways that we can look at ion notation. What are the oxidation numbers themselves? Remember, we talked about those. Those are like what the charges are called, is oxidation numbers. That is the specific charge that atoms get once they become stable. Remember that they want to have full outer energy levels. They want their valence electrons to be full in whatever outer energy level that they have. Remember, that's like the noble gases. The noble gases have full outer energy levels. And so the way that they do this is that they, again, either gain or lose electrons. So magnesium has 2 valence electrons. It could either gain 6 to get to 8, or it could lose those 2. It's just going to lose those 2 valence electrons, and that is going to make it be magnesium with a +2 charge because it has 10 electrons now and 12 protons still. Oxygen, on the other hand, is going to gain 2 electrons. It has 6 valence electrons to start with, right? So it's got 6 valence electrons here to start with. It's going to gain 2 electrons, and when it gains those 2 electrons, it's going to have a -2 charge because it's going to have 8 protons and 10 electrons. So remember, atoms want to have their outermost energy level be full, and in order to make that happen, they need to be gaining or losing electrons. Now, again, this is just a little bit of a review. You should have already written this down. If you haven't already, make sure you do that. This is the trend of the oxidation numbers on the periodic table, and we're going to need this trend in order to be able to figure out things with compounds that we talk about this unit. So remember, group 1A has a +1 charge, group 2A has a +2 charge, group 3A +3, 4A is plus or -4, can either gain or lose, and then 5A -3, 6A -2, 7A -1. And remember that the that the noble gases over here have a 0 charge because they already have full outer energy levels. They don't want to gain or lose electrons. Okay, so again, that's all the kind of review that we want to go over. Let's talk about what we're actually going to be talking about this unit, which is compounds. How do we make compounds? How do we talk about the bonds that are being used to form compounds? So just a little bit of a review. Remember that compounds are a kind of pure substance where 2 or more different elements are chemically bound together, right? So over here on the right-hand side, you can see these are our compounds. We have water would be an example of a compound. You have 1 oxygen and 2 hydrogens, right? And there are chemical bonds holding these together. You could also have hydrogen and chlorine, right? This would be another example of a compound, different elements being held together. Now, you can also have molecules of elements. Remember, we kind of talked about this before, where you could have something like H2 or O2. There are still chemical bonds that are holding these together, but these would be still considered elements and not compounds because you have the same kind of element holding them together. In this unit, we're going to be focusing on compounds. So what are chemical bonds? Well, chemical bonds are formed when 2 atoms are stuck together because of interactions between their valence electrons. So what we're talking about here when we talk about chemical bonds is we're talking about valence electrons interacting between different atoms. And that's why we spent last unit talking a lot about valence electrons and why we just kind of reviewed that, because it is the valence electrons that are important when we talk about chemical bonding. Bonds form because elements want their outer energy levels to be full, and so they have to interact with other elements or other atoms in order to make this happen, right? They need to be either giving their electrons to another atom or getting their electrons from another atom. There are two main types of chemical bonds, which are your covalent and ionic bonds. There is also a third type called metallic bonds. We're not going to be worrying about those in this class, but just so you know that there is another kind of bond called a metallic bond. Okay, so I went too far. So this little table is just going to kind of break down, help us organize the main differences between the two different types of bonds, which are covalent bonds and ionic bonds. So in a covalent bond, electrons are shared between atoms, okay? In an ionic bond, electrons are transferred from one atom to another. Now, this may be a little confusing. Again, we're just putting this information down, and then I'm going to go through and explain it in just a moment. Covalent bonds are used to form molecular compounds. Ionic bonds are used to form ionic compounds. So that's pretty straightforward. In a covalent bond, you will only be seeing non-metal types of elements. Remember that your non-metals are the elements that are to the right side of the periodic table. So if we pull up a periodic table real quick, right? Remember that your non-metals are those that are on the right side of the periodic table, so to the right of the staircase, the nice dark black line here, right? Or hydrogen. Remember, hydrogen is also a non-metal. Your metals, remember, are to the left of the staircase. Now, remember, we do also have some elements called metalloids, right? So I'll just mark those real quick. These are the metalloids. Remember that these are kind of along the staircase. Sorry, polonium is not one, astatine is. So just don't forget about those as well. Okay, so those are your metalloids. Metalloids in these kinds of things would be generally considered to be non-metals in terms of determining whether or not it's a covalent bond or an ionic bond. Okay, so for a molecular compound or that's held together by covalent bonds, it's going to be your non-metals only. For an ionic bond, it's going to be both metals and non-metals. All right, so let's talk a little bit more specifically about what's actually happening here for a covalent bond. Again, I said that valence electrons were going to be shared between atoms to fill their outer energy levels. So if we take a look here, right, remember that hydrogen only has one energy level. And so in order for its first energy level to be full, it just needs 2 electrons. So here, right, we have hydrogen, we've got the 1 electron being shared, right, from each. And so when they bond together, when they form this covalent bond, now they each have 2 because they're sharing them together. Similarly, right, carbon has 4 valence electrons. It is going to bond with 4 other hydrogens. Each hydrogen is going to share 1 with the carbon. The carbon is also going to share 1 electron with each hydrogen. And so if you look, the carbon now has 8 valence electrons, which fills that outer energy level. And each of the hydrogens has 2, which fills its first energy level. And we can see that process repeated here with the chlorine. When the chlorines bind together, they each share 1 electron with each other, meaning that they each have a total of 8. And again, with the water, we can see the oxygen down here is bonding, and it's going to be sharing electrons with the hydrogen. The hydrogens are sharing with it. The oxygen ends up with 8, giving it that full outer energy level, and the hydrogens each end up with 2, again, because they only have the first energy level that fills that energy level. Notice that, again, this is only non-metals that are being involved here, okay? So, and that's because all of the non-metals want to gain electrons. Because they all want to gain electrons by sharing, they kind of are gaining, right? By sharing, they get to work together, and this is going to make them happy. This is going to make them all stable. And so this is how we form a molecular compound with a covalent bond. In an ionic bond, valence electrons are transferred from one atom to another. Okay, so the valence electrons are going to be passed from one atom to another. And when that happens, that creates the ions. This is where we talk about the oxidation numbers and ions, right? In an ionic bond, by transferring electrons from one atom to another, the atoms become charged. So in this example down here, sodium is passing one electron to fluorine. When it does that, when it gets rid of that electron, it becomes positively charged. When the fluorine accepts the electron, it becomes negatively charged. So we have a positive ion and we have a negative ion, and because they're opposites, remember that opposite charges attract, they're going to be forming that ionic bond with each other. And again, an ionic bond occurs between metals and nonmetals because metals want to get rid of their electrons, right? They want to get rid of them. They want to become positively charged. Nonmetals want to gain electrons. They want to become negatively charged. And so if you pass the correct number of electrons from a metal to a nonmetal, you're going to form a ionic compound with an ionic bond. Here's a little visual to help you reminder. You are going to need to be able to look at a compound, okay? Look at the name of a compound or look at the formula of a compound and be able to determine whether or not it is an ionic compound or a molecular compound. So here's a little flow chart. Make sure you fill this out in the notes, all right? Where you are going to, that's going to help, right? Basically, what you want to do is just look at the name of the compound and determine, is it made up of two nonmetals or is it made up of a metal and a nonmetal? If it's two nonmetals, then it's a molecular compound. If it is a metal and a nonmetal, then it is an ionic compound. So that's all you need to know. It's pretty straightforward. Let's do a little bit of practice. All right, so first example is NaCl. Okay, NaCl is sodium chloride. We'll talk about how you need to name that a little bit later. So here is our periodic table. And so let's take a look. Where is sodium on the periodic table? Well, sodium is over here on the left. Remember, everything way to the left of the staircase is going to be a metal. So that's a metal. And here is chlorine. Chlorine way over here on the right. That is a nonmetal. All right, so we've got a metal and a nonmetal. And so since we have a metal and a nonmetal, what I like to do is sometimes come over here and to draw an M and an N. So it helps me remind, okay, that's a metal, that's a nonmetal. And so therefore, this is going to be an ionic compound. Okay, so that's an ionic compound. If we take a look over here, we've got water, H2 and O. So the two, and we're going to talk about this more later, the two references only to the H, okay? So these subscripts only reference to the one that comes in front of it, right? So the H, right, that's hydrogen. Let's go to our periodic table. Hydrogen is up here. So let's get rid of these. So hydrogen is up here, right? So there's hydrogen, and then here is O. Now, you're probably thinking to yourself, oh yeah, H way on the left side of the periodic table, definitely a metal. No, remember, hydrogen is our one exception to the rule. Hydrogen is a non-metal, okay? And that's a little confusing, but just remember, hydrogen is a non-metal, even though it's on the left side of the periodic table. Oxygen, definitely to the right of the staircase, definitely gonna be a non-metal. And so here we have a non-metal and we have a non-metal. And so because we have two non-metals, this is going to be a molecular compound. Okay, that's a molecular compound. So what you need to do now is you need to go through and finish the rest of the notes practice sheet. Make sure you go through and write in your summary, and then underneath the summary on the last page is some practice where you need to practice identifying them, these activities or these molecules as either ionic or molecular compounds. So make sure that you've gone through and filled out all of the, notes. And down here at the bottom, you need to go through and you need to write in whether or not it's ionic or molecular. I recommend doing what I was just doing, right? Writing M and N for, metals and nonmetals above the elements to help remind you. And so just make sure that you're going through and answering all of those. And then remember, don't forget to submit it once you are finished. Okay? So thanks for watching, and I'll see you next time.